Hi everyone, welcome to my channel. My name is Fikrat. This video continues series dedicated to learning Microsoft Fabric. In the last video, we started discussion around programming objects within Synapse Warehouse. So we explored user-defined functions and stored procedures. And I mentioned that when it comes to user-defined functions, you can only create table-valued functions in Synapse Warehouse. If you have a legacy warehouse based on databases, the chances are they have lots of Scalar user-defined function in these databases. So you might be wondering how to convert Scalar user-defined functions to table-valued functions if you want to migrate to Synapse Warehouse. So I decided to make a quick video to share my experience of converting Scalar functions to table-valued functions. Join me to learn more. Let's first clarify what are Scalar functions and how they are different from table-valued functions. Scalar functions may receive multiple parameters and do some calculation based on these parameters and return a single value. So scalar functions are typically used within select list where you want to have a new calculated column, and in many cases you supply columns from your parent query. So in other words, you have a parent query, and within your select list you may have one or more scalar functions, and as a parameters you may pass certain parents fields. In contrast, table-valued functions are functions that produce data sets. So you cannot refer them within select list, but you can treat them as parameterized tables. Let me explain this on the example of sample functions that I created based on AdventureWorks. So AdventureWorks is a sample Azure SQL database, and it represents sales data. So let me just quickly show this table list. I have a script here which creates samples of scalar and table-valued functions. I will be sharing this script in the video description. So let me walk you through this script. The first command between lines 2 and 16 creates scalar function. You can see that it receives two parameters, price and quantity. So this function is multi-statement scalar function. You can also create a single statement or inline user-defined functions, which are easier to convert to table-valued functions, but I selected multi-statement functions to make this example more interesting. So within this function, I have a first command which calculates total cost based on total cost by multiplying price and quantity. So these are two parameters supplied to this function. And the second statement is if-else statement. So basically I compare this total cost to certain threshold, and based on different condition, I assign different values to category variable. I already created this function, so let me scroll down and show how we can use this scalar function. So my next statement queries sales order details table, and one of the columns is user-defined function. Let me run this command, and it will bring you unit price, order quantity, as well as a calculated category column. Now let's see how this function can be converted to table-valued function. So my next command has similar create function statement. However, in this case, I have table as return type for this function, and I have return statement which returns a single query. There are two important parts of this conversion logic. First of all, as you can see, I am relying on common table expressions here. So common table expressions in SQL is a great tool to create multi-step queries. So in many cases, it can help you to split complex query into smaller steps. So what I have got here is common table expressions that calculates total cost. And you can see that I am multiplying price to quantity, which are parameters to this function. And then I query from this common table expression here, and I apply additional calculations in my select list. So as you can see here, I am using native conditional functions to make comparison of total cost to a given threshold value. And based on different conditions, this if function will produce one of the provided parameters. So if it's less than 5,000, it will produce the first argument. If not, then it will do another check, and so on and so forth. So basically, this single expression replaces this entire conditional section here. And here is how you would use table valued function in combination to your parent queries. So here's my parent query, and I'm using cross apply construction. And so here's my table valued function, and as you can see, I supply unit price and order quantity columns from my parent query, and then result from these table valued functions is included in my select list. So let me run this. And as you can see, my output is identical to Scalar function output. So to recap, I have converted two-step Scalar function to single-step inline table valued function here. The beauty of this solution is that you can convert as many steps using this logic, because common table expressions allows you to create multiple steps. So far I have created both functions in my Azure SQL database, but this table valued function syntax will work in Synapse Warehouse as well. So at the bottom of the script, you will find a command that will create a sample sales table with 2 rows and 2 columns. And the last query will read from this sales table and apply table valued function. And it works fine on Synapse Warehouse. I should mention that table valued functions are preferred option when it comes to performance, even in traditional SQL databases like Microsoft SQL, on-premise Microsoft SQL, or Azure SQL. So converting Scalar functions to table valued functions will help you to improve performance, even if you are not migrating to Synapse Warehouse. Having said that, there are some exception cases that will probably prevent you from refactoring things like cursor logic in your functions. If you happen to have cursor logic, your common table expression idea will not work. However, I found that some of the cursor logic can also be converted to single statement query. That's it for today. I hope that was helpful. Feel free to share your experience of refactoring Scalar functions, and thanks for watching.